Hi, hello, welcome to Homeschool. This is your Class 8 Mathematics NCERT or CBSE board. We are in our second chapter, Rational Numbers. In this session, we are going to discuss how to represent the rational numbers on a number line. Along with other numbers also we are going to see. Number line representation of natural numbers. Let me start from 1 point and I just show you here an arrow. A natural numbers representation on a number line. What are natural numbers? Counting numbers are called as natural numbers. That is 1, 2, 3, 4. These are all called as natural numbers. Right? Let me start from 1, 2, 3, 4. See here towards right side. Numbers I am writing towards right side. Where it ends? Don't know. Number line starts from 1 and it extends indefinitely towards right side. Okay. Then coming to whole numbers. Whole numbers, number line starts from 0, 1, 2, 3, 4, 5. So on it continues. See here, whole numbers representation on a number line, it starts only from 0. We cannot represent -1, -2 on this number line because whole numbers representation on a number line. That means it starts from 0 and it extends towards right side indefinitely. Okay, where it ends, we don't know. But it extends only towards the right side. And it have positive numbers along with 0. In this way, we represent whole numbers on a number line. Next, representation of integers on a number line. You can see arrow mark here and here also. Can you see? What does it indicate? The line, number line extends towards right side and also towards left side. Let us mark in middle 0. Towards right side, positive numbers. Towards left side, negative numbers. Integers on a number line. This number line extends right side indefinitely and also left side. But whereas here, it starts the number line from this point but it does not extend towards left side. Whereas in integers, the number line extends towards left side and also right side. And 0 will be middle, this side are positive numbers and this side it will be negative numbers. In this way, we represent integers on a number line. Now coming to the present topic, that is representation of a rational numbers on a number line. It extends towards left side and also right side. And I am going to start here with natural numbers 1, 2, 3, 4, 5, so on, 0, whole numbers. Now along with the negative numbers, we call them as integers. See here, on this rational numbers on a number line, I can show you natural numbers along with whole numbers and along with integers. Now where are rational numbers? Okay, let us go back here once. This is the representation of natural numbers on a number line. Can you see in between 1 and 2, is there any other natural number in between them? No, there is no other natural number. After 1, you get only 2. There is no other natural number in between them. Coming to whole numbers. Between 0 and 1, can you see any other whole number? No. After 0, you get only 1. There is no other whole number in between these two numbers. Coming to integers. In between any two numbers, suppose let me take -3, -2. Can you see any other number inside? If you say -2.5, it is not an integer. I am asking here, can you say any other integer in between these two integers? No, there is no other integer in between these two integers. Now coming to rational numbers on a number line. All the numbers are subsets of rational numbers. Natural numbers will be there in rational number, whole numbers will be there, and integers will be there. Then what is extra here? Can you see any rational number in between 0 and 1? You may say 0.1, 0.2, 0.3 decimals. These are all the rational numbers. Or I may divide it into two parts and say this is 1 by 2, I will say. Is this a rational number? Yes, it is a rational number. Half, right? So what does this half indicates? See here, half 1 by 2 is a fraction. And here, this we call it as a numerator and this we call it as a denominator. Yes or no? Now, how we are saying this one? 0 to 1, right? This is divided into two equal parts. And here, this 2 in the denominator says that number of parts you have done. How many parts I have done here? 2 parts. 1 unit length is divided into 2 parts, right? And numerator shows the number of the part. Denominator shows number of parts you have done. And numerator shows the number of the part you are saying. So here I can say 1 and 2. 2 divisions done and this is the first part 1 by 2. Similarly, suppose if I take same 0 to 1, I am going to do 3 divisions. 1, 2. 3 divisions I am saying and I have put 2 marks now here. Look here. 1, 2, 3. 3 divisions by putting 2 points here. Okay. How many parts I have done? 1, 2, 3. Denominator indicates number of the parts you have done. So here I write it as 3. How many parts? 3, no? 1, 2, 3. Right? And this is the first point. First part I am talking 1 by 3. And this one is, I have done here 3 parts. Denominator shows the number of parts. How many parts you have done? That will indicate the denominator. Whereas numerator, this is first part already completed and here this is second part. I am moving towards right side, right? 1 by 3, 2 by 3 and this one it is 1, right? I can write this as third part, right? 3 by 3. 3 by 3 is nothing but 1. Okay, try to understand carefully. And I am going to take one more here. Suppose if I take 0 to negative side, -1 I am saying here. I am going to divide into 4 parts. How many? 4 equal parts. 4 equal parts means how many points you need to mark on this line? Only 3. 4 parts you need to do means you need to mark 3 points. 1, 2, 3. Okay? How many parts it is divided? 4. 1, 2, 3, 4. Right? Total parts will be indicated in the denominator. And this is the first part, right? 0 to towards left side. It will be negative, -1 by 4. And coming to next point, -2 by 4. 4 will be as it is. Denominator won't be changed. Now this one, -3 by 4. And this one if you want to say, I can say this as -4 by 4. That will be -1. Okay, try to understand the concept carefully, children. Representation of number line. So now I am going to mark between unit length one point. Look here. Each unit length is divided into two parts. So let me write in this way. Look here carefully. 0 by 2 will be 0. And next one will be 1 by 2. Next one will be, each part is done into two parts, right? Next one 2 by 2. And next one 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, 8 by 2, 9 by 2, 10 by 2. Observe here. Observe carefully. 0 by 2 will be 0, 1 by 2, 2 by 2 will be 1, 3 by 2, 4 by 2 is again 2, 5 by 2, 6 by 2 is 3, 7 by 2, 8 by 2 is 4, 9 by 2, 10 by 2 is 5. See here, in between points, what you can say? 1 by 2, 3 by 2, 5 by 2, 7 by 2, 9 by 2, like this also you can say. Same manner, you can mark this side. How you can say? Minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, minus 5 by 2, minus 6 by 2, like this. Understand the concept carefully here. Each unit length is divided into two parts. Each unit length is divided into two parts. So from 0, if I start 1 by 2, 2 by 2, 3 by 2, 4 by 2, like this I have done here. And negative side along with the negative number I have written. Okay, towards the left side I have written with the negative side. Now let us take a rational number. I think every one of you know that. Rational number, any number which can be represented in the form of p by q, it is called as a rational number. If nothing there, you imagine that q is 1 and where q cannot be equal to 0. You know this all right. P is numerator and q is denominator, right? And you know that fractions, proper, improper, and what is a mixed fraction, these all you know. So let us recollect that and then we are going to represent rational numbers on a number line. Suppose if p is less than q. Suppose if p is less than q. That means let us take an example 2 by 3. 2 by 3. Then what type of a fraction it is? It is called as a proper fraction. Yes or no? Suppose if p is greater than q. Example 3 by 2 you take. P is greater than q. 3 is greater than 2, no? 3 by 2. Then which type of a fraction it is? It is improper fraction. Improper fraction, again you can convert into mixed fraction. How you are going to do this? Convert this improper fraction into mixed fraction. Divide 3 with 2. 2 ones are 2 and you are left with 1. So this one you are going to write it as 1 by 2. 1 by 2. You need to write the quotient here and remainder here. Let us take another example here. 7 by 3. Divide this. 3 2s are 6. 7 minus 6 will be 1. How we are going to write 7 by 3 in mixed fraction? This can be written as denominator won't be changed as it is you are going to write. And now here side you need to write 2. Remainder you need to write here. How we are going to write? 2 whole 1 by 3rd. 2 whole 1 by 3rd or 2 1 by 3 you can say this. 7 by 3 is an improper fraction. This can be written in the form of 2 1 by 3. Any rational number will be in the form of p by q where q is not equal to 0. Suppose if p is less than q, that is numerator is smaller than the denominator, it is a proper fraction. And suppose if Numerator is greater than the denominator. It is improper fraction. Improper fraction we can convert into mixed fraction. 2 by 3 represent on this number line. 2 by 3 and I take 5 by 3, 8 by 3 represent these three rational numbers on a number line. How you can represent here? Suppose if your rational number is a proper fraction. Suppose if it is a proper fraction, the proper fraction lies between 0 to 1. Lies in between 0 to 1. Proper fraction lies between 0 to 1. So, 2 by 3 proper fraction and these two are improper fractions. 2 by 3 lies in between 0 to 1 and one more thing observe here. Denominator indicates number of equal parts. Okay, and this one indicates second part. Okay, 2 of 3 parts you can say. Have to represent 2 by 3. Suppose if it is started from 0. Each 1 by 3rd part you need to take and you need to mark here. Look here carefully. First one will be 1 by 3. Second one will be 2 by 3. And third one will be 3 by 3. That is nothing but 1. Each unit is divided into 3 equal parts. 1, 2, 3. Denominator shows the number of parts it is divided and numerator shows the part which you need to mark on a number line. I need to mark here. So let me round it up. 2 by 3 on a number line. And next 5 by 3. 5 by 3 is not a proper fraction. Let us convert 5 by 3 into improper fraction. How can you write? 3 ones are 3. Right? So what is a remainder you are going to get? 2. 1, 2 by 3. Or when you want to convert this mixed fraction into improper, have to convert mixed fraction into improper fraction. We need to multiply these two and then that product you need to add for this 2. 3 ones are 3. 3 plus 2 will be 5. 5 by 3 is the improper fraction. Now here itself you can see 1 whole 2 by 3. 1 whole means 5 by 3 lies in between 5 by 3 lies in between 1 and 2. 1 and the next number. 1, 2 by 3 lies in between 1 and 2. Okay. So next, how you are going to represent this? Similarly, you can go with 4 by 3, 5 by 3, 6 by 3, 7 by 3, 8 by 3, 9 by 3 like this. Okay. So every unit is divided into 3 equal parts. This is 4 by 3, 5 by 3, 6 by 3. See here, this is the one you need to answer. 6 by 3 is nothing but 3 2s are 6, this is 2. And this is 3 3s are 9, this is 3. Right? 1 whole 2 by 3 I can say this. 1 whole after 1, second one is 5 by 3. Is it right or not? After 1, second part is 5 by 3. 1, 2 by 3. 1, 2 by 3 is this one. Okay. Next, 8 by 3. 8 by 3 I can say directly. Or you can convert this 8 by 3. Where it will be lying means just convert into mixed fraction. 3 2s are 6. 2. Right? 2 by 3. 8 by 3 lies in between 2 and 3. 8 by 3 lies in between 2 and 3. And where it will be? 2 whole 2 by 3. 2 whole 2 by 3. After 2, second one is 8 by 3. Is this clear? This way we need to mark any rational number on a number line. In your textbook, try this. You have these two number lines. Fill the missing rational numbers in between the number line. So observe here carefully. 0 by 5. Towards right side all are positive. Observe here 0 by 5 means each unit is divided into 5 equal parts. 0 by 5 and this will be first part of 5 equal parts. 1 of 5 equal parts. How can you write? 1 by 5. Right? 2 by 5, 3 by 5 and this is 4 by 5 and this will be 5 by 5 you can say or 1 also you can say. Okay? 6 by 5, 7 by 5. Next number will be 8 by 5, 9 by 5. So they asked to find the missing rational numbers A, B, C, D, E is 1 by 5, 4 by 5, 5 by 5, 8 by 5 and 9 by 5. Here what you need to understand, each unit length is divided into 5 equal parts. Okay? Next one. See the next number line? All are with negative. From 0 towards left side all are negative. We need to mark now negative rational numbers here. 6 indicates each unit is divided into 6 equal parts. And here first part among the 6 equal parts is minus 1 by 6. And next second one will be minus 2 by 6, minus 3 by 6, minus 4 by 6. And the next minus 5 by 6. H minus 7 by 6. I minus 8 by 6, minus 9 by 6, minus 10 by 6 and this will be minus 11 by 6. Like this, what you need to understand here, each unit is divided into 6 equal parts. 0 is there here and minus 1 is here. Right? From 0 and 1, observe here carefully. 1, 2, 3, 4, 5, 6. Yes, each unit is divided into 6 equal parts. Similarly here, observe here 5 equal parts said, no? From 0, 5 by 5 means 1, right? From here to here observe 1, 2, 3, 4, 5. Each unit is divided into 5 equal parts and every part distance is 1 by 5. 1 by 5 again plus 1 by 5 will be 2 by 5. 2 by 5 again plus 1 by 5 will be 3 by 5. Right? Every unit is divided into 5 parts. Each part is 1/5 of the distance. Okay, is this clear? Now, let us take our own number line and we are going to represent some rational numbers. Okay, let me take here 3 by 7 and minus 5 by 2 and one more 7 by 10, 6 by 2. Let me take a number line and observe here carefully. Numerator and denominator, which is greater? Denominator is greater. Then this fraction is what? Proper fraction. Proper fraction, what you can say? It lies in between 0 and 1. This is proper fraction. These 2 points you need to observe by seeing any rational number. This is a proper fraction, lies between 0 and 1. Each unit is divided into 7 equal parts. So this is positive, right? 0 to 1. 7 equal parts. 1, 2, 3, 4, 5, 6. 7 no? 7 means 6 points you need to mark in between 0 and 1. And you need to mark 3 by 7. Third one among 7 equal parts. Third one among 7 equal parts. 1, 2, 3. This is 3 by 7. 4 by 7, 5 by 7, 6 by 7, 7 by 7 is 1. Is this clear? 3 by 7, how you need to represent? 3 by 7 is a proper fraction. It lies in between 0 and 1. So 0 and 1 is divided into 7 equal parts. Third part is 3 by 7. Next, minus 5 by 2. Minus 5 by 2. Don't observe negative sign. If you observe negative sign, you say it as a proper fraction. When you are observing this, forget about minus. 5 by 2 only you observe it. 5 by 2 is a improper fraction. Improper fraction convert into mixed fraction. Minus as it is you take. 5 by 2. 5 by 2 how we are going to convert? Divide 5 by 2. 2 2s are 4. 5 minus 4 will be 1. Divide here. Minus as it is you take. 5 by 2. 2 2s are 4. That is 5 minus 4 will be 1. Denominator won't be changed. Denominator as it is you write. Okay. And now here you need to write the quotient. Quotient is how much? 2. And here remainder. 2 1 by 2. 2 whole 1 by 2 you can say. Right? 2 1 by 2 you can say, or 2 whole 1 by 2 you can say. This fraction is a improper fraction. So improper fraction we have written in the form of mixed fraction. Why? We need to understand here this is improper and the rational number minus 5 by 2 lies in between minus 2 and minus 3. For this sake, I have converted into mixed fraction. Minus 2 and minus 3. So take a number line. From which point 0 you take, but I need only from minus 2 to minus 3. Okay. How many parts it is done? 2 parts. How many parts? 2 parts is done. Every unit length is divided into 2 parts. Right? Now, minus 2. From 0 to minus 2 means here. Minus 2 1 by 2. In 2 parts, first one. This part indicates minus 5 by 2. Right? Don't say 1 by 2. It is the first part of 2 equal parts after minus 2. Right? Minus 2 1 by 2 is nothing but minus 5 by 2. Is this clear? Like this we need to mark minus 5 by 2. Suppose if I say here any 7 by 2, I say minus 7 by 2. Same minus 7 by 2. Where you are going to mark? Convert this into mixed fraction. How we are going to convert? Minus 3 1 by 2. 3 1 by 2 means after minus 3. After minus 3, first one is minus 7 by 2. Right? Like this. Observe carefully. And while you are marking on number line, don't write minus 2 1 by 2. Don't write. After minus 2, first part you write it as minus 5 by 2. Next, other 2 examples here. 7 by 10, mark on a number line. It is a proper fraction. Numerator is smaller than the denominator. Proper fraction, where does it lie? It lies in between 0 and 1. 0, 1. Okay, I have expanded a little. How many parts I need to do this one? 10 equal parts I need to do. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 means only 9 points, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I need to mark 7 by 10. 7 of 10 equal parts. 7th one of 10 equal parts. From here start counting. 1, 2, 3, 4, 5, 6, 7. This is 7 by 10. 8 by 10, 9 by 10, 10 by 10 is nothing but 1. Are you able to understand? In this way you need to do the number line. Next, 6 by 2. I know that 6 by 2 is nothing but it is 3. So 0, 1, 2, 3. This is the point where you need to mark. Now let us see the next concept. Rational numbers between two rational numbers. How many rational numbers will be there in between any two rational numbers? Any two rational numbers. Let us take with an example and say this answer. Let me take the first example. How many rational numbers are there? These are two rational numbers. Here denominator is same, right? First thing we need to observe is denominator is same or not. If it is same, see here 3 by 10 on a number line, you can remember 3 by 10 after what you are going to get? 4 by 10, 5 by 10, 6 by 10, 7 by 10. But between means I say only these three. Between I should not use 3 by 10 and 7 by 10. Only these three rational numbers are there. Okay, let us check it out. For the given 3 by 10, I may multiply 10 for numerator and denominator. Then what does it become? 3 into 10, 30 by 10 tens are 100. 30 by 100 is nothing but 3 by 10. Do you accept? 0, 0 cancel 3 by 10. 30 by 100 or 3 by 10 both are same. Same manner, this denominator also I will convert it to 100. That means 7 by 10 into 10 by 10. 7 into 10, 70. 10 into 10, 100. Now say the rational numbers between 30 by 100 and 70 by 100. How many you are going to say? 31 by 100, 32 by 100, 40 by 100. Many you can say, but I am skipping many rational numbers and I am writing 45 by 100, 65 by 100, 69 by 100. See here, up to 69 by 100 you can say. But in between these, there are many. Many means how many you can say here? 70 minus 30. 70 minus 30, it will be 40. One number you need to reduce. That means 39 rational numbers will be there in between these two with the same denominator. For 3 by 10, suppose if I multiply 100 for numerator and denominator, it will be 300 by 1000. Same manner, 7 by 10 if I multiply numerator and denominator with 100, it will be 700 by 1000. Now say me 300 by 1000 and 700 by 1000 in between these two, how many rational numbers will be there? So observe here 301 to 699. 301 to 699 means how many? 301 to 699. That will be 398 rational numbers will be there in between these two. So not only this children, any number you can multiply for this, make the denominator same, and then you can see many rational numbers. These are all the numbers, these are all the rational numbers are in between these two numbers only. So finally what I can say, how many rational numbers will be there? There are infinitely many rational numbers will be there in between any two rational numbers. Suppose if they ask you any 5 or 10 or 6, any rational numbers between given two numbers means you can write among this any numbers. Okay, those all numbers should be inside this rational numbers. Right? So let us move to the next example. Write 10 rational numbers between minus 5 by 6 and 5 by 8. What is the first step you need to remember when you are writing the rational numbers? Make sure the denominator is same for both the rational numbers. minus 5 by 6 and here 5 by 8. Okay, so denominator here it is 6 and here it is 8. Make same. How you can do? So this 8 I can multiply here 8 by 8 and here for 8 this 6 I will multiply numerator and denominator. Now what happens? Minus into plus will be minus. 8 5s are 40. 8 6 are 48. Minus 40 by 48. Okay. And here this one 5 6 are 30 and 8 6 are 48. So the rational numbers between minus 40 by 48 and 30 by 48 you find out. How many you need to find, children? You need to find 10 rational numbers between these two. Imagine here negative numbers towards left side of the 0 and positive numbers towards right side of 0. Here minus 40 by 48 and here 30 by 48. So each division 1 by 48 there. So you can write many numbers. Let us start writing between numbers. You should not write these two. Right? I will write here minus 39 by 48, minus 38 by 48, minus 37 by 48, minus 37 by 48, minus 30 by 48. Randomly I am writing minus 20 by 48, minus 10 by 48, 0 by 48, 10 by 48, 12 by 48, and this side all positive now after 0. So I write here how many numbers over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 number I write. 29 by 48. See here, among these rational numbers in between these two also, I have picked only 10 rational numbers. You can write the 10 rational numbers of your own choice. I have written here minus 20. If you want, you can write minus 23 by 48. Right here minus 28 by 48. Yeah, wish you can write. Is this clear? Like this, you need to write the rational numbers in between them. Okay, let us take one more example here. Suppose write 5 by 3 and 7 by 2. Any 3 rational numbers. Write 3 rational numbers between these two. Between these two, immediately what you should remember? Make the denominator same. Here denominator 2, here denominator is 3. So multiply 2 for this numerator and denominator. That will be 10 by 6. And here 3, this 3 multiply 21 by 6. 10 by 6 and 21 by 6. See 3 rational numbers. 11 by 6, 12 by 6, 13 by 6, 14 by 6, 15 by 6. Like this, up to 20 by 6 you can say. Yes or no? 11 by 6, 15 by 6, 20 by 6. Only 3 as 3 I have written. Okay. First, in the given 2 rational numbers, try to make the denominator same by multiplying the denominators of other rational numbers, and then you can see the middle numbers. Is this clear? Let me take another example here. Write 3 rational numbers between 1 by 4 and 1 by 2. Okay, 1 by 4, immediately what do you say? 1 by 4, 1 by 2 there. So I can multiply for this rational number numerator and denominator 2. This becomes 4. Yes or no? So directly only one set you can change. Or if you want to change, you can multiply 2 for this numerator and denominator, and for this 4 for numerator and denominator. Then it will be 2 by 8 and this is 4 by 8. Another way also you can do, I said, that is 1 by 4 as it is, and for this 1 by 2 you can multiply 2 by 2. That will be 2 by 4. 1 by 4 and 2 by 4 you can find, or 2 by 8 and 4 4 by 8, you can find. Both are same. If you cancel, what happens? 1 by 4. And this is as it is. If you cancel this 2 by 4, it will be 1 by 2. So you need to write in between these two rational numbers, 3 rational numbers you need to write. So look here, 2 by 8, 4 by 8. 2 by 8 and 4 by 8, only one rational number you can see. So 2 by 8 and 4 by 8, in between, can you write 3 rational numbers? No, I have only one rational number with the same denominator here. Observe here carefully. No need of writing in between these two numbers. Okay, go back. Again go back and multiply for this. One more pair. Again I will multiply 2 for numerator and denominator. And here also 2 for numerator and denominator, and check what we are going to get. So check here. 2 2s are 4, 4 by 16. And here 4 2s are 8, 8 by 16. Yes, now I can write 4 by 16 and 8 by 16. Can you say 3 rational numbers? Yes. 5 by 16, 6 by 16, 7 by 16 are the 3 rational numbers between these two rational numbers. Now 3 rational numbers, it is possible. Suppose if they give you 10 rational numbers, 10 is it possible here? No. Then multiply with some other number and then try to write the 10 rational numbers. So this can be done in another way. Suppose if any 2 rational numbers are there, suppose A and B are the 2 rational numbers such that the rational number between these two is A plus B by 2. Such that A is less than A plus B by 2 is less than B. If A and B are 2 rational numbers, then A plus B by 2 is a rational number between these two numbers. Right? Suppose if I take same A and B, 1 by 4 and 1 by 2. What is A plus B by 2? This is A value, this is B value, right? Add these two. Add these two, what happens? LCM, 4 and 2 LCM is 4, 1 plus 2, 3 by 4 you are going to get. Okay? 3 by 4 by 2. By 2 means 3 by 4 into 2 by 1 there here. So do the reciprocal and multiply. It will be 3 by 8. So what you can say here? In between the 2 rational numbers, 1 by 4 and 1 by 2, 3 by 8 will be there. Okay? 1 by 4 is less than 3 by 8 and 3 by 8 is less than 1 by 2. Okay, are you able to follow? Now, if you need to write 3 rational numbers between these two. Now again, these two, any one rational number you find in middle. That means, again same process continues. Take 1 by 4 and 3 by 8. See here, these two middle means A plus B by 2 you do. Now this is A and this is B. Right? Do LCM. It will be 8, 2 plus 3, 5 by 8. 5 by 8 into 1 by 2, it will be 5 by 16. Now this 5 by 16 will be here. Yes. Again one more needed. 3 rational numbers, right? So between these two, find another rational number between these two. Again same formula. A plus B by 2. 3 by 8 plus 1 by 2 will be 8 LCM, 3 plus 4. That will be 7 by 8. Half you need to do now. That means into 1 by 2, 7 by 16. 7 by 16. 3 by 8 is less than 7 by 16, less than 1 by 2. Suppose you need 2 more extra. You can find between these two, or you can find any of the 2 rational numbers, between numbers also you can find. When you are writing the rational numbers, between 2 rational numbers using this, denominator may not be same. Don't be confused. Either this way you can do or this way also you can do. Is this clear? Now the three rational numbers between 1 by 4 and 1 by 2 is 5 by 16, 3 by 8 and 7 by 16. You can write any rational number because there are infinite number of rational numbers between any two rational numbers. Is this clear? I hope everybody followed this.